Greetings, dearies.
Hello.
Welcome to this lesson 1B. In our last session, we just managed to define terms, understand what probability is, how to calculate probability, and laid out some rules of probability, types of events. Now, we want to look at some examples, and then I'll bring another part. We will then later do a session where we just go now to past exam paper questions dealing with these things we are covering now. Okay?
Yes.
So these first sessions are just introductory, but we are getting a picture of what will be happening in the exam. Let us look at this example here from 2016. It says, the probability of events A and B occurring are denoted by P of A and P of B respectively, right?
Yes.
Then for any two events A and B, it is given that probability of what? Are you able to read this?
Yes.
What does it mean? This one. Not B. Okay?
Yes.
This is the same as saying probability of not B or B complement. Are you there?
Yes. Yes.
Good. So immediately, before I even go far, since they gave me this, I know there's a connection. Probability of B plus probability of B complement or not B should be equals to what?
1.
1. Correct, right?
Yes.
Which now means from this we can get probability of B by saying probability of to be 1 minus probability of B complement, which is 1 minus 0.28. What do you get?
0.72.
0.72, right?
Yes.
So I already have this idea because I know there's a connection here. I know something that probability of B plus probability of B complement should be 1. Then I found B,
Yes.
right? Okay.
Yes.
Then they continue to say probability of B is equals to 3 times probability of A. Now, I know that I can get probability of A by dividing both sides by 3, right?
Yes.
Because B, we already know it now. Okay, that is good. Let us go on. Probability of A or B is equals to 0.96. All of this is data being given, but because you saw something you know, you must jot it down so that you'll be at peace. Okay?
Yes.
All right. Now, the question now comes and say, are the events A and B mutually exclusive, right?
Yes.
So we said when they ask you this question, you are trying to check. This is what you are checking. To check what? Probability of A.
A and B is equal to 0.
That's what you want to check. Are we there?
Yes.
So you can't start by writing this as a solution. It means you are starting somewhere else until you arrive at a point where you are able to conclude. Okay?
Yes.
If probability of A and B turns out to be 0, you conclude that events are mutually exclusive. If somehow you get an answer which is not 0, you conclude that the events are not mutually exclusive. Okay?
Yes.
Now that we are aware of what exactly we need to find, then we start looking at the data given and see how do we connect any of the information given to involve probability of A and B, right?
Yes.
And our connection is here. Probability of A or B for any two events, it has a formula, right?
Yes.
What is that formula? Do you remember it?
It's PA plus PB minus PA and B.
PA and B. Good, right?
Yes.
Now, do you see that this formula, it has A or B, which we are given,
Yes.
but it also carries what we want to test, A and B. Do you notice?
Yes.
So it is a good formula because it will help me check what I want to see. But now, looking at it, the formula involves probability of A and probability of B. The data gave you probability of B complement, but the formula needs probability of B, but we were already ahead of time and we saw this thing coming, okay?
Yes.
So on probability of B, we are covered, right?
Yes. Yes.
So we want probability of A. We said it's probability of B divided by 3 from this formula, right?
Yes.
Which is 0.72 divided by 3, right?
Yes.
So all of this you'll be doing there on your answer book, all right?
Yes.
Okay. Then what do you get if you divide?
0.24.
0.24, right?
Yes.
Okay. Done like that. Then after we now have everything. So where there's probability of A or B, I'll put 0.96. Do you agree with me?
Yes.
Where there's probability of A, what do I put?
0.24.
0.24. Then where there is probability of B,
0.28.
28 is for
No,
not B.
0.72. 0.72.
Good. Then minus probability of A and
A
B,
and
right?
Yes.
This which I wrote here, it is not part of my solution. In fact, I'm considering it to be part of my question. That's the actual thing they are asking, right?
Yes.
So let us simplify. It's algebra, 0.96. If you add 0.24 plus 0.72, what do you get?
0.9. 1.92.
0.24 plus 0.72. Are you sure?
0.96.
Uh-huh.
Yes.
Like this, right?
Yes.
All right. So our job is to find probability of A and B. So do you see that I can transpose and have it on the other side?
Yes.
Okay. Then I have this 0.96 this side. Then this one will cross also, it becomes minus, right?
Minus. Yes.
So in the end, probability of A and B is equals to 0, right?
Yes.
So we got this answer by calculation, but to us it means something. What do we conclude about events A and B? Therefore, events A
Exclusive.
are mutually exclusive.
Yes.
Okay.
Yes.
Only because probability of, since probability of A and B is 0, right?
Yes.
It means if we had done this calculation and got a different number here, let's say 0.1, 0.2, 0.5, we would conclude that the events are not mutually exclusive. You understand?
Yes.
Good. Can I move on?
Yes.
All right. So that's 4 marks for you. Then another one. In 2015, it said, for any two events, A and B, it is given that probability of A is 0.2, the probability of B is 0.63. This is just repetition here, okay?
Yes.
Okay. I made a mistake on typing. Now, so, and probability of B is 0.63, then probability of A and B is 0.126. That's information given, right?
Yes.
Then the question says, are the events A and B independent, right?
Yes.
So the actual thing we want to check is what? Do you remember? What do we check?
Yes, that the probability of A and B is equal to PA multiplied by PB, probability of B.
Like this, right?
Yes.
Again, I cannot write this as a stage in my solution. This is what I want to check, okay?
Yes.
So as it is now, it is part of the question. I'm just making sure that I am making it easy to know what I'm looking for. However, the way to write this answer is, do you see that probability of A and B is given?
Yes.
What is the value?
0.126.
0.126, right?
Yes.
All right. Now, from here, let us look at probability of A separately times probability of B. Do you see what we are doing? We are taking the numbers now. So you have 0.2 times 0.126, okay?
Yes. No. Isn't it 0.63?
63, sorry, 0.63. 0.63. What do you get?
0.126.
0,126, right?
126. Yes.
So here is what we will now observe. We did this separately. We were given that probability of A and B is 0,126, but we did a product separately. But what do you notice about the answers?
They're the same.
They're the same. So now it is safe to say, therefore, probability of A and B is equals to probability of A times probability of B. We are now writing this because the calculations have shown us. Are we there?
Yes.
Therefore, events are independent. Are you there now?
Yes.
That's how you conclude. So the way you present your answer, if you write this as a stage of your answer, you have already accepted that events are independent. Do you see that?
Yes.
So it is supposed to show through numbers, through calculation, that these things turn out to be equal. Okay?
Yes.
Done. So that's another kind of questions you come across. All right?
Yes.
But before we close the session, I want to introduce something that will continue in the other sessions. Okay?
Yes.
So we have what we call tools of probability. Tools
Okay.
of probability.
Is this grade 12?
Mm-hmm.
Okay.
Tools of probability.
Yes.
In fact, it also has 10 and 11 in it. We have tree diagrams.
Okay.
Have you heard of them before?
Yes.
We also have Venn diagrams. Grade 10, right?
Yes.
Then we also have contingency tables.
Yes.
Right?
Yes.
Okay. So, as we have these things, let's start by looking at tree diagrams first, okay?
Yes.
Okay. So, we'll do these things, then we have more time to look at different questions in another session, okay?
Yes.
So, for now, in this session only, we'll manage to discuss tree diagrams, okay?
Yes.
These ones, they help on events. They help on, let me use the word consecutive. They help on consecutive events. Consecutive events, i.e., events happening one after the other, okay?
Yes.
After the other. Then, when we deal with them, when you deal with tree diagrams, there are two kinds. Another one, there is with replacement, okay?
Yes.
Then another one, there is what we call without replacement, okay?
Okay.
All right. So tree diagrams, they help on consecutive events, things that are happening one after the other. For example, if you come across a question that say he picked and he'll pick the second time, you understand? He drew and you drew again. You draw again. So those are events that are happening one after the other. So a tree diagram represent those things nicely, okay?
Yes.
All right. So the best way to explain it is with an example. Is it fine?
Yes.
Mm-hmm. So it says a box contains 3 green balls, but remember, we already know how to calculate probability. Number of over total. Agreed?
Yes.
So a box contains 3 balls and 5 blue, 3 green and 5 blue. These balls are identical except for color only. Do you know the balls that are used in a game of pool or snooker?
Yes.
You see, they are the same, right? Except for color. You cannot,
Yes.
if I let you close your eyes and you touch those ones, You cannot tell me, oh, this one feels like green. You can't feel a color, isn't it?
Yes.
Good. Now, so that they are the same except for color. So John decides. Now, when you are given questions, you are trying to pick what leads you to an idea or a formula. Look at this. John decides to randomly pick a ball out of the container, right?
Yes.
2 times. You see this?
Yes.
Replacing. So this part which says 2 times is already directing you to consecutive events. Are we there?
Yes. Okay.
So your mind is already singing tree diagram. Are we there?
Yes.
Then it continues to say replacing. Now you have reduced it to tree diagrams where there is picking with replacement. You understand?
Yes.
With replacement. So that's what we are talking about. Now, let us look at what comes next. The question now says, what is the probability of picking a green and a blue ball? Okay?
Okay.
Okay, so now let me give the box first. If this is the box, then we have how many which are green? 3, right?
Yes.
1, 2, 3 are green. Then blue, we have 5. So let's put blue 5. 1, 2, 3, 4, 5, right?
Yes.
Are you with me?
Yes. Yes.
So to draw this tree diagram, how many colors do we have involved here?
How many? 2.
2 colors. We have green and blue, right?
Yes.
Good. It means when you draw your tree, it has how many branches?
2. 2.
2 branches. So for starters, you have another one for green, another one for blue for the first time, right?
Yes.
Then if he continues to pick again for the second time, the colors will still exist as green and blue. Are you there?
Yes.
And again, it happens to be green and blue, right?
Yes.
Then on this side here, the end, you will have what we call possible outcomes. Okay?
Yes. Yes.
Okay. Now, so from this which we have, what is the probability of picking green for the first time?
3/8.
3 over 8, right?
Yes.
And what is the probability of picking blue?
5/8.
Is the other twin still there?
Yes.
Understanding this?
Yes.
Good. What you need to understand is if you add, you see on these branches coming from the same node, if you add their probabilities, you should get 1. Okay?
1. Yes.
What we are talking about is, I can give you a diagram that only has 3 over 8 like this, right?
Yes.
And ask you what is the probability of B. So what you do is, you just say 1 minus 3 over 8. You will get 5 over 8. You understand?
Yes.
Okay. So these branches should add up to 1. Now, as you draw the tree, I want to make a statement that will make sense sooner on the without replacement. You need to follow the same color. Let's say you are saying John picks green first, right?
Yes.
He has picked green. That the probability there was 3 over 8. Agreed?
Yes.
But this is picking with replacement, so he puts it back again. So what is the probability of picking the second time?
3/8.
It is still the same. Are you there?
Yes.
Because the number of green ones is still 3 and the total is still 8. Are we good?
Yes.
Then to get for blue, you just do 1 minus 3 over 8. You will get your 5 over 8. Are you with me?
Yes.
All right. Now, that's it. Then let us look at the other branch. So you follow blue and blue. You are saying, what if he picked blue? Okay. The probability was 5 over 8. Now he replaced it. It is back in the container. What is the probability of picking blue again?
5 over 8.
5 over 8. So what is the probability of picking green?
3 over 8.
3 over 8. Okay.
Yes.
Now, when you are done like this, you have completed drawing the tree diagram. You need to focus on the possible outcomes now. So we are saying he picks green and green. He can pick a green and a green. He's picking twice, right?
Yes.
So he can pick a green and a green, or what? Green and a blue. You are here now. Or a blue and then a green, or a blue and a blue. These are the possible outcomes. Do you see that?
Yes.
But pay attention to what I'm saying. He can pick a green and. Do you see that in between there is and?
Yes.
Do you see that?
Yes.
Or do you see that?
Yes.
So he can pick a green and a green, or a green and a blue, or a blue and a green, or a blue and a blue, right?
Yes.
Good. We said that and, it means times, okay?
Yes.
Or it means plus, right?
Yes.
All right. Let us now look at the question. When you are done like this, you now have the ability to answer the question. So check this out. It is saying, what is the probability of picking a green and a blue ball, right? Okay.
Yes.
This question is not specific about the order. It is not saying green first and blue. No, it is just saying green and blue. Okay.
Yes.
So it means in the end, we want a scenario where John managed to have touched a green and a blue ball, irrespective of order. So you have green and blue. We are considering this one. Or he could have started with blue and then green. In these two cases, John managed to touch a green and a blue. Do you understand?
Yes.
But if the question was specific to say, what is the probability of picking green first and blue, then we would only consider this one, because here it's not starting with green. You understand?
Yes.
So the probability of green and blue, we are now saying the answer, probability of green and blue, either John will start, pay attention to the words, either John will pick green and then blue, or John will pick blue first and then green, right?
Yes.
We said and means times, agreed?
Yes.
So it means probability of green times probability of blue, or means plus, right?
Yes.
Probability of blue times probability of green. Are you following?
Yes.
Okay. Now, what is probability of green? It's 3 over 8, right?
Yes.
We are following now the branches, green and blue. So it's 3 over 8 times 5 over 8. Are you seeing this?
Yes. Yes.
Okay. Times 5 over 8. Then plus, for this, it's 5 over 8. Then times 3 over 8. Are we there?
Yes.
Even though we have reached tools of probability, it still remains a rule that answers of probability should be between 0 and 1. Okay?
Yes.
Now, punch it for me. What do you get?
3 over. Um, 0,46875.
Yeah? 0,
0,47.
7. What was it as a fraction?
As a fraction, it was 15 over 32.
15 over 32, okay?
Yes. So
right.
it's preferable to write it as a fraction.
Across all topics, I would prefer if you write exact answers. That means fractions, sets. Are we there?
Yes. Okay.
The reason to this is I want you to make it a habit so that in the exam, especially when you go to finance, you see, if you get a decimal and you round it off, when you use it again in the next calculation, your answer will lose accuracy due to what is called rounding error. Okay? So exact answers are preferable. Okay? Are we fine?
Yes. Yes.
Oh, okay. Then let us answer the second question here. It says calculate the probability of picking balls of the same color, right?
Yes.
For same color, do you see that we are talking about either green and green or blue and blue? Do you see that?
Yes.
So to answer number 2, we are saying to answer number 2, probability of same color. Let me just do it on the side here. Probability of same color is equals to either green and green, right? Or
Yes.
blue and blue. Are you there?
Yes.
Okay. Then green and green, we remember the probabilities here is 3 over 8, right?
Yes.
Times 3 over 8. Then plus 5 over 8 times 5 over 8, right?
Yes.
What do you get?
Mm. 17 over 32.
17 over 32. We are done. Are we there?
Yes.
So that was picking without replacement, okay?
Yes.
Now, let me move this a bit and I show you picking without replacement. Then we end this session, okay?
Okay.
So what I did is I used the same example and changed only one word into 2. Look at this. A box contains 3 green and 5 blue. You remember these words, right?
Yes.
These balls are identical except for color only. John decides to randomly pick a ball out of the container 2 times. Already, this is what is directing you to a tree. Okay?
Yes.
After all is done, remember you will be having many things that you know. Tree diagrams, Venn diagrams, contingency tables. You already know the things we did before. So you want something that directs you to an exact idea to apply, right?
Yes.
So events are consecutive. Then it now says without replacing. So this is now picking without replacement, okay?
Yes.
So everything else is the same except for this part. So here's what will happen. Let me draw the container for you. Then we have how many green? 3.
Yes.
1, 2, 3. Then how many blue? 5, right?
Yes.
Okay, so if 1, 2, 3, 4, 5. Okay, that's our container. So since we have 2 colors, we need 2 branches, right?
Yes.
Okay, we need 2 branches. One for green and one for blue. Agreed?
Yes.
What is the probability of picking green?
3 over 8.
3 over
8. 8.
8. What is the probability of picking blue?
5 over 8.
5 over 8. Now, the branch grows again. So we have green and blue again, right?
Yes.
Then we also have green and blue, right?
Yes.
Now, so this one is picking without replacement. So that's where I was saying it is easier to follow the same color, green to green. Let's say he picked green and he kept it. He did not replace, right?
Okay.
What is the probability of picking green now?
2 over 7.
2 over 7. Is the other twin with us?
Yes.
Good, good. Now, 2 over 7. So to get this one, you just say 1 minus 2 over 7. What do you get?
5 over 7.
5 over 7. Check this. We have how many blue? 1, 2, 3, 4, 5. In a total of 7, right?
Yes.
So if you don't follow the same color, it will be painful to say you got 3 over 8. Then you want to discuss blue. It is not easy.
Yes.
Are we there?
Yes.
Okay. Now, let me replace that bow again, the green one. And we are saying, okay. What if he starts by picking blue, right?
Yes.
So probability was 5 over 8. And if he picks a blue one and keep it, What will happen to blue? What will be the probability again?
4/7.
4/7, right? And what will be the probability
Yes.
of green? 1 minus 4/7. What do you get?
3/7.
3/7. You follow, right?
Yes.
Then again, you go to possible outcome.
Okay.
Are you there?
Yes.
So with possible outcomes, we are now saying green and green, or green and blue, or blue and green, or blue and blue. You see this? Are you with me? Hello?
Yes.
Now, if you look at the question, is saying, what is the probability of picking a green and a blue ball? So we answered this already in the first question. Green and blue. It's either green and blue or blue and green, right?
Yes.
The rest is the same. We only needed to pay attention to this without replacement. So you finish these questions